Hey guys, I'm Dao Shen from Taipei office. I want to say sorry to you guys because this is midnight time in Taiwan, so I'm not sure I could join your meeting, so I record a video to you guys first. Currently, I'm working on the media and the graphic part of Smart TV, and I also research on how to increase gaming experience. But on my spare time, I'm also interested in WebVR, so you could see I did a lot of VR demo on my GitHub. Today I want to show you how can I make the VR demo on Cardboard and Oculus have the unified experience. The demo used the LeapMotion to control the camera position, and the demo I also bring to the booth in Whistler for Josh and the WebVR team. So I think they also are excited about it. So let's start our WebVR demo first. Okay, for this demo I prepared some devices. The first device is Sony Z3C, Firefox OS inside. So you could see I have a support WebVR mode. I can rotate the device and you can control the orientation of the 3D camera. Another is Google Cardboard and the LeapMotion. The last one is Oculus SDK 2. So, okay, first let me demo how to use the LeapMotion control the position of 3D camera in this scene. So I use the gesture on my LeapMotion, so you can control forward, move forward, backward, forward. Okay, I also can rotation my camera and move forward. Oh, sorry. Move forward. Move backward. Okay. So when you bring in the Google Cardboard, that will be so special WebVR experience. Another demo is using Oculus. Okay. In this Oculus demo, we can see Oculus head-mount display can help us control the orientation of this camera. When I into the full screen mode, WebVR API have support distortion filter. It's very good. The same as Cardboard demo, I still can use the LeapMotion to help me control the position. So head-mount display, the sensor help me control the orientation, and the LeapMotion help me control the position of this camera. So we might see a good solution for us because right now we didn't have a good enough controller in our 3D game thing. So LeapMotion is a very good device for us. Okay, let's start today's presentation. Okay, let's start the presentation. In this presentation, I want to tell you how can I make this demo, and this is very simple, and I want you guys also can know how can I make it. First, this demo is based on 3.js. On 3.js, there are some WebVR module right now. So for the developers, it's very simple for them to finish your WebVR demo. And I also a contributor of 3.js, so I am very familiar with 3.js. In my demo currently, I can support Oculus and the Cardboard mode at the same time, and I can provide unified experience for them because I think it's very important for them because we don't want a content provider have to rewrite their code or convert their asset. Just want to support the two different modes on WebVR. So this is user friendly. It's not user friendly. So I want to prove the same code and the same content can support the two VR modes at the same time. The last thing is LeapMotion SDK. LeapMotion SDK provides the JavaScript API for us to communicate with the LeapMotion and our any devices. Okay, on 3.js there are two modules for us. The first module is VR effect.js. In this code, we can get VR device, the hand-mount display device, and it can support stereo render and the full screen distortion filter. And the other is VR controls. In this API, we can get the orientation and the precision from precision spacer of VR device. Right now, just in Oculus mode, we can get a precision of precision tracker. On Oculus, on Cardboard, we have no idea right now. Okay, first, I want to tell you how I made the demo on Oculus. It's very simple. When you using the 3.js, you just write down just a few line codes. First, you have to get the state of your precision sensor. If your precision sensor support orientation, you can just send the orientation to your object. In my demo, I want to control my camera, so I send to my 3D camera. Also, if your device support the precision, for example, for Oculus, you can get the precision of your 3D workspace. So if you have the precision tracker on your computer, so you can get the precision and send to your camera or any objects. Finally, you have to call device effect render, and it will provide the stereo render and the full screen distortion if you enable the full screen mode. So it's very convenient for developers. On Cardboard, we have to make a minimum and just a few line modification. Because on the Cardboard, the initial position is flat on your device, but for Google Cardboard mode, the device must be in front of your eye. So in your code, you have to rotate about 90-degree angles on the x-axis. So you can see I write a few lines on this part. First, I get the orientation from the position state, and I get the position from the ULA angles, and I minus the ULA angle x 90 degree, and I set the angle to camera again, so I can create the orientation for cardboard. So let me use the picture to describe the problem more deep. Because the initial position is like this way, so we have to rotate about 90-degree angle to let they can face to our eyes in front of our eyes. So we need to rotate about 90-degree angle. In LeapMotion, it's also very simple for us. LeapMotion have support the WebVR SDK for any device if you using the TCP/IP. First, you have to construct the connection to LeapMotion. So first, you use the WebSocket protocol. You write your IP address of your computer and get the v6 JSON, and you will connect the device successfully. When you successful connection, you have to set some configuration for LeapMotion. First, it depends you want to enable the gesture or not. For my demo, I needed to support the complex gesture, so I disable it. Complex gesture, and you have to set the focus to true. If the focus is enabled, it will start to track your gesture. Yeah. Another thing is when the message is received, you have to talk your object to update its transformation. So I get my hand, the first hand. I just focus my first hand, and I get the paranormal. The paranormal has 3 axes. The third axis will help me to get the normal of the Lee axis, and I use the Lee axis to control my camera. So it's very simple for the developers. So if you use the WebVR API and the LeapMotion SDK, you can control your camera in 3D sim very friendly, and it not will spend a lot of time for you. At last, I have a few thoughts I want to share you guys. First, I know you guys spend a lot of time on Oculus. Therefore, Oculus mode is pretty good right now. However, on Cardboard mode, I think we still have a lot of job we can improve it. First, the update frequency of orientation is not good enough. Just a few months ago, I still have to use a device orientation API. It is pretty bad, and it's a nightmare for us because we can find lots of latency. Right now, it's a good news for us. We can use the position orientation from WebVR API, but it is a little bit slow, and even on the Fnac Android Firefox browser, it's also slow. But on Firefox OS, it's the worst. On Firefox OS, its API is always slow and sometimes will bring the latency. So we can find a way to fix it and let the update frequency be higher. Third, the Cardboard mode still cannot enable full screen or distortion filter. Probably I have to check the gecko for Cardboard mode and figure out what is the reason. At last, magnet event. Magnet event is pretty important for Google Cardboard. We can store lots of demos from Google Cardboard. This event can help us trigger an event to control the content, provide some interaction of the controllers. For example, when we play a video on our VR, we can trigger the event from magnet to control the play or start event of the video. So we still have to find a way to enable magnet event for WebVR on Cardboard. Okay, that's it. This is my presentation. Thanks for your attention. If you have any question about my demo or my presentation, please feel free to send me a mail. I will reply shortly. Okay, have a good day.